to everybody that is connected, and welcome to the virtual 2020 annual meeting and expo live stream. We're going to wait for another 4 minutes before we start our presentation. So please stay connected, and we'll get back to you. Thank you. Okay, we're ready to start. Welcome everybody again. Good evening and good morning, depending on when you are. And welcome to the virtual 2020 AOCS annual meeting and expo. This is one of our live stream presentations. My name is Silvana Martini. I'm a professor in food science at Utah State University. And today I have the pleasure to introduce Dr. Hironori Hondoh, who is going to talk about the effects of tripalmitin and tristearin on the crystallization and melting behavior of coconut oil. Dr. Hondoh is an associate professor in food physics at the School of Food and Nutritional Sciences at the University of Shizuoka in Japan. He received his master's degree in physics on a topic related to protein crystal growth from Tohoku University, and a PhD in protein crystallography from Osaka University. He worked as a postdoc in the fields of crystal growth, enzymology, and start application. In 2010, he joined the faculty at Hiroshima University and started his career in food science. Last year, in 2019, he moved to University of Shizuoka, and he is head of the Laboratory of Food Physics. He's going to give a presentation today, and we're going to collect questions. You are welcome to write your questions in the Q&A tool that you have in your Zoom, and we will answer the questions at the end of the presentation. The presentation should be about 20 minutes. So I'm looking forward to the presentation and to the discussion that we'll have afterwards. And with that, I will turn over the floor to Dr. Hondoh. Thank you.
Okay, thank you very much, Professor Martini. I will share my slides. Okay, does it work? Okay. So,
yes.
Hello everyone. My name is Hironori Hondoh from the University of Shizuoka, Japan. First of all, I'd like to thank to the organization committees for giving me to join this wonderful virtual conference. It is my great pleasure to give a talk to you. This work is a part of my PhD student, Ms. Mahisanant. So she will get a PhD on this summer. Today, I'd like to talk about the application of triacylglycerols as additives for the crystallization of coconut oil. As you know, the coconut oil is a healthy oil. The coconut oil is known as a healthy oil. Coconut oil is rich in medium chain triacylglycerol, and their metabolic pathway in the digestion and absorption are different from the long-chain fatty acid triacylglycerols. Medium-chain triacylglycerol can help the excess calorie burning and weight loss. Therefore, coconut oil is important in South Asian countries. To control the crystallization of fat, some techniques were used. The well-known technique is the template effect by additives. If additives have the similar fatty acid moieties to the target crystals, the additives crystal will work as a template to promote the fat crystallization. However, the mechanism is still obscure. Heterogeneous nucleation is a more common concept in the field of the crystal growth. A surface or interface will help to reduce the nucleation barrier compared to the homogeneous nucleation, even they have no specific interactions between the target fat and substrate. So for example, dust or container wall will act as a substrate for heterogeneous nucleation. Recently, the idea of the epitaxy also introduced in the fat crystallization. The oriented growth of one crystalline materials on the single crystal surface of the different material is called epitaxy. In this case, in the case of the ionic crystals, they are so simple structures. The lattice matching is a factor to determine the epitaxial growth. However, in the case of the molecular crystal, like fat crystals, molecular structure and the packing in the crystal should be considered. The interaction between the substrate and the target molecules will be similar like in the pure crystals. Recently, we reported the epitaxial growth of permit fractions on the emulsifier crystals. When the fatty acid moiety of them are similar, the permit fraction crystals grew in the same orientation as the emulsifier crystals, while permit fraction randomly oriented on the surface of the emulsifier when the emulsifier have the different fatty acid moieties. But in both cases, permit fraction crystals were promoted on the surface of the substrate. Therefore, both are heterogeneous nucleation And the case of when they have the similar fatty acid moieties, specific interaction between the permit fraction and the substrate induced the epitaxial growth. This system was fat and emulsifiers. So here we try to understand the interaction between the triacylglycerols by using the tripalmitin and tristearin on the coconut oil crystallization. So in this research, we applied the tripalmitin and tristearin as additives for the coconut oil crystallization. The concentrations of the additives and the cooling rate were varied to evaluate the effect of additives on the crystallization of coconut oil. So we used a high melting point fraction, high melting point triacylglycerol, PPP, and tristearin, since we want to observe the crystallization behavior from molten state. So these additives are mimicking the minor component in the natural fat. We expected these additives will crystallize first, and then coconut oil crystallization will follow. Here, again, the purpose of this study is to investigate the effect of the tripalmitin and tristearin additives on the crystallization of the coconut oil and to understand intermolecular interactions between them. Next, I will explain the materials and the method. So this is a scheme for the sample preparation. The triacylglycerols was added to the coconut oil and melt completely over the 80 degrees C. These samples were applied for the further experiment to observe the thermal behaviors with the differential scanning calorimetry and the morphologies with the optical microscopy, and we determined the polymorph with the synchrotron radiation XRD. Here we show the temperature profile in these works. First, the materials are heated over the 80 degrees C to melt completely, and then cooling for the crystallization. This cooling rate were changed from the 2 degrees C to the 10 degrees C per minute. Crystallization behavior and the melting behaviors under the different cooling rate was investigated with the different DSC and optical microscopies with these temperature profile. And isothermal crystallization at 15 degrees C also observed. Synchrotron radiation XRD measurement were also carried out in the same cooling rate here. We determined the polymorph of the crystal from the wide angle X-ray diffractions and the type of the triacylglycerols molecules from the small angle diffractions. This was performed at the photon factory in Tsukuba. Okay, so let's move on to the result. The first, I'd like to tell the result with different additives. The left shows the synchrotron XRD patterns for the crystallization of the coconut oil. First, peak of the alpha form at the 0.412 nanometer was observed, and then beta prime at 0.43 and 0.38 appeared. On small angle diffractions, the corresponding peaks for them are found at the same time as wax diffraction, 3.84 and 3.29 nanometers. So now we call these first alpha crystals as the high TC alpha, and this beta prime is a low TC beta prime. Addition of the tripalmitin also shows similar patterns to the coconut oil. the induction, the crystallization occurred a little bit higher temperatures compared to the coconut oil, but the profile was quite similar. In contrast, addition of the triacylglycerol changed the XRD patterns as shown here. The beta prime form was crystallized directly from the melt without alpha form. In addition, the shape of the peaks shown in the wax regions is sharper than the one of the low TC beta prime. Like here, this part is dull, but here is very sharp. And the lamellar distance shown in the Sachs peak was also different from the one of the low TC beta prime. This one was a 3.34 nanometer and the low TC beta prime was a 3.28. So this polymorph shown with the triacylglycerol must be different beta prime crystals from the one obtained with the coconut oil or with the tripalmitin. Next slide shows the melting behavior of the coconut oil measured by the synchrotron XRD. When coconut oil was heated, the high TC alpha was disappeared here around 12 degrees C, and then beta prime peaks became sharper as shown here. On the sex regions, the low TC beta prime peak was broadened when the high TC alpha was disappeared. So the both high TC alpha and the low TC beta prime were transformed into the another beta prime form. We call this one as a coconut oil beta prime, CO beta prime. So the coconut oil with the triacylglycerol did not show any polymorphic transformation during heating, and the lamellar distance was the same as a beta prime that transformed from the high TC alpha and low TC beta prime. This body was 3.35 and this one was 3.34. So this means the triacylglycerol promoted the crystallization of the more stable beta form, CO beta, beta prime form, CO beta prime form from melt. Next slide shows the DHC thermogram in the crystallization of the coconut oil with a different cooling rate. As shown here, the coconut oil showed the two crystallization peaks. The pattern was changed when the cooling rate was changed. However, they consist of the two peaks under these conditions. These peaks are corresponding to the high TC alpha and the low TC beta prime, respectively. The crystallization temperature with the fast cooling was lower than the slow cooling, since it can reach a lower temperature before crystallization started. With additives in both cases, tripalmitin and tristearin, the crystallization temperature were increased compared to the coconut oil, and under the cooling rate. However, the coconut oil with the triacylglycerol showed a single peak under the 2 and 5 degrees C per minute in cooling. When the cooling rate was increased to the 10 degrees C per minute, the profile became similar to the coconut oil itself. So the triacylglycerol could change the crystallization behavior of the coconut oil as shown in the previous slide. This is a synchrotron XRD of the coconut oil with the triacylglycerol under the different cooling rate. As shown in the previous slide, high TC alpha and low TC beta prime were separately crystallized when the cooling rate was high. Therefore, the addition of the triacylglycerol kinetically promoted the crystallization of a stable CO beta prime form. This is a DSC sumgram with different concentrations of additives. Addition of the tripalmitin slightly increased the crystallization temperatures of the coconut oil, especially the high TC fractions. But the crystallization profile did not change. Crystallization of tripalmitin was confirmed when the concentration was increased to the 3%. At the 10% ppb tripalmitin, the coconut oil crystallization peak became a single as shown here, implying the CO beta prime formation. In the case of the triacylglycerol, 0.5% of the triacylglycerol provided almost a single peak of the crystallization. And the crystallization temperature of the CO beta prime was increased with the increase in the concentration of triacylglycerol. Lastly, I'd like to tell about the isothermal crystallization of the coconut oil with additives. The left is the DSC thermogram of the isothermal crystallization at the 15 degrees C, and the right is the integrated enthalpy of the crystallization as a function of time. The slope of this graph will indicate the growth rate of the crystals. And the green arrow here indicates the time for the induction time of the crystallization. So the additives reduce the induction times with the tripalmitin and the triacylglycerol compared to the coconut oil here. And with the triacylglycerol, the growth rate was significantly increased compared to the coconut oil. The next slide shows the morphology of the coconut oil crystals during the isothermal crystallization. The top is the coconut oil itself, and the bottom two with the additives. We couldn't see any difference between the coconut oil and the coconut oil with a tripalmitin as shown here. The crystallization of the tripalmitin could not separately observed. In contrast, the addition of the triacylglycerol showed many spherulite here, small particles as shown here. So that means the triacylglycerol, the crystallized are in the early stage of the crystallization. And the spherulite crystals of the triacylglycerol will promote the crystallization of the coconut oil. When these crystals were heated, the melting behavior was similar as shown here. The coconut oil crystals disappeared when the temperature reached to the 25 or 24 degrees C. And at the same temperatures with triacylglycerol, also the coconut oil was disappeared, but the tiny spot of this triacylglycerol still remain here. And the dissolving melting of the triacylglycerol was confirmed the DSC as shown here. So let me discuss about the mechanisms of the tripalmitin and the triacylglycerol promoting the coconut oil crystallization. Actually, we showed some result, but the polymorph of the additives were not clear yet. So there are many discussion can be done, but just let me show some possibility. The tripalmitin, of course, they consist of the palmitate, but they have the similar structures to the coconut oil because coconut oil contains a longer fatty acid, like around 10% of the palmitic acid and 15% of the myristic acid. So between them, there could be some specific interactions. And then especially the high TC alpha, this should be consist of the high melting fraction triacylglycerols with a longer fatty acid. So this PPP, tripalmitin, can promote the crystallization of the high TC fractions. That's why the addition of the tripalmitin can promote the crystallization of the high TC alpha. And tristearin was kinetically promoted the crystallization of the coconut oil beta prime. CO beta prime is a more stable form, and of course, if the condition was different, this CO beta prime can be crystallized directly from the melt without the tristearin. But with the tristearin, I think these additives can provide some interface for the specific or non-specific interaction. It is not sure yet, but the tristearin is much longer than the coconut oil. So I guess it's a non-specific interactions, and the surface can promote any crystallization by the heterogeneous nucleation. So with this effect, the crystallization barrier for the coconut oil beta prime was reduced, and this stable form can be crystallized. Let me conclude my talk. We try to investigate the effect of the triacylglycerols on the coconut oil crystallizations, and under the different cooling rate and the different concentration and different type of the triacylglycerols. And we found that the tristearin can promote the formation of the stable coconut oil beta prime form from melt directly under the slow cooling. And tripalmitin can promote the formation of the high TC alpha form and the low TC beta prime form, both of them. So the mechanism is still unclear. I think our next paper is coming soon, and with this papers, we will explain the detailed interactions between the triacylglycerols and the coconut oil. Thank you for your kind attention.
Thank you, Dr. Hondoh. Very interesting presentation. So now we're going to open the floor to some questions. We do have a question already. And the question is, what is the application area of triacylglycerols added to coconut oil?
Well, one of the application is for the fractionation. The additives can promote with the tripalmitin, the high melting point, the high TC alpha form. So we guess this fraction contains a higher melting point fractions. So with these applications, the addition of the triacylglycerol will help to fractionate the coconut oil.
Great, thank you. Great application. I do have a question, if I may.
Sure.
I'm not going to write it. I'm just going to ask it.
Okay.
So on that, you showed a really nice plot of solid fat content of the isothermal crystallization at 15 degrees Celsius.
Mm-hmm.
Did you see any changes in polymorphic form there, or do you think it's just the same beta prime that you formed at the beginning?
We haven't checked the XRD, so we can say from this profile, but they are crystallized in the CO beta prime form, I think. because the temperature is very high compared to the previous experiment, the cooling crystallization. And at these temperatures, they can crystallize in the beta prime form.
Great.
CO beta prime form.
Good. Are there any other questions out there? Well, I don't see any more questions. If, I mean, I think this presentation is going to be available. So if participants have any other questions afterwards, they are more than welcome to pose questions or to email Dr. Hondoh directly. I think, I believe this paper was published in JOCS, so they can always refer to the paper. With that, I would like to thank Dr. Hondoh for this wonderful presentation and for willing to do this online virtual presentation, and also AOCS for organizing everything.
And Silvana, it looks like another question just came in.
Yes.
You don't mind.
Yeah, thank you, Amy. So the next question is, what do you think will happen if you use cocoa butter POS?
Well, you mean the POS contain the PPP, palmitic and stearic acid. So which one is more effective, right?
I would think the question is, I don't know, is if you're using POS as a seeding material, I would think.
As a seeding material, right?
Right, instead of triacylglycerol or tripalmitin.
Yeah. So of course, I'm not sure, but melting point of the POS is much lower compared to the PPP and SSS. So we need a more higher concentration to see the effect of the POS, and they will be crystallized together, I think. So the effect is like the addition of the tripalmitin.
Great, thank you. And we do have another question if you have the time. It says, the next question says, do you think that the addition of tristearin can make dynamic crystallization of palm kernel oil possible?
I think so. I forgot the components of the palm kernel oil, but it should be similar to the coconut oil. And I think the addition of the tristearin will change the the profile of the crystallization.
Great.
It can provide a more stable form, I think. I mean, change to be the more stable form.
Perfect. Well, now I think we don't have any more questions. So with that, we'll thank you again, Hironori, and I hope you have the rest of a good day today, and everybody else have a good night, and we'll see you all. We will see you all online.
Thank